Yo, what's up everyone? Patrick here, welcome back. Moving on to the next topic dealing with the elasticity. We're still on the elasticity section, so we're going to talk about perfect inelastic versus perfect elastic demand in this video. So to do a quick little recap of what we've covered, we talked about the price elasticity of demand, and we also introduced the coefficient, and depending on the values of the coefficient, we classified that certain good or service. So if that coefficient was equal to 1, then that good or service was considered unit elastic. I'm actually going to expand this spectrum a little bit. And then if that coefficient was greater than 1, we classified that good or service as being elastic. And then if it was less than 1, it was considered inelastic. So what does perfect inelastic and perfect elastic demand mean? Well, it's actually the ends of this spectrum here that I drew out. So starting on this end, if a good or service is right on this end here, it's going to be considered perfect inelastic. It's going to have perfect inelastic demand. And the value of the coefficient on this end of the spectrum is going to equal 0. Versus on this end, if a good or service falls on this end, it's considered to have perfect elastic demand, and the value of the coefficient is going to be infinity on this end of the spectrum. So let's talk about both of these one by one. So let's start with perfect inelastic. Let's dig into a little bit more detail. What does it mean when that coefficient is going to equal 0? And just to do a quick review of that coefficient, it's basically equal to the percentage change in quantity demanded over the percentage change in price. So how can we take this ratio and make it equal to 0? When is it going to equal 0? Well, notice it's going to equal 0 when the numerator is equal to 0. And then the denominator can just be any kind of number. If you have 0 divided by any number, you're always going to end up getting 0. Okay, so that's when a good or service is considered perfect inelastic. When there's a change in price, but there's no change in quantity demanded. So for most goods and services, according to the law of demand, that demand curve should look something like that, right? So for a high price, there's less of a demand. And then for a low price, there's more of a demand. But if a good is considered perfect inelastic, how is that going to look graphically? Okay, so we got quantity demanded down here, we got price over here. So let's say that a good or service has this price here. Let's call it P0. And then at this price, let's say that it has this quantity over here. That's the quantity demanded. Well, if it's perfectly inelastic, what's going to happen if we increase the price to P1? That quantity demanded is not going to change. It's going to stay 0. So it should go down for most goods and services according to the law of demand. But again, there are some goods that are perfectly inelastic, so that quantity demand, it's not going to change. So it's going to stay the same. And so it's going to look like this. And so if we connect these two dots, it's basically just a vertical line. And the reason why is because that quantity demanded is not changing with that change in price. And when that's happening, we end up getting a coefficient of 0. Or this doesn't necessarily have to be 0, but it's going to be a very small number. Right? So if this is a very small number, right, this might be tilted a little bit, but nevertheless it's going to be very close to a vertical line. If it's perfectly inelastic right on that edge of the spectrum, it's going to be a vertical line like this. So you'll see this kind of diagram coming up in textbooks, and the reason why it's a vertical line is basically because of that reason here. And there's not too many goods and services in the market that have perfectly inelastic demand. A good example of a couple is certain healthcare products where there isn't a lot of competition in the market and there's a monopoly and there isn't a lot of substitutes. Actually, a very controversial thing that happened relating to this a few years back was there was a guy named Martin Shkreli. He's in jail now. If you want to Google his name, basically what happened was he bought a pharmaceutical company, and this pharmaceutical company was creating a drug called diaprim, I think it's called, or diaprim. It basically treats toxoplasmosis, and what happened was before he bought the company, the drug was worth $13. That's what patients were paying for it, or $13.50, something like that. And then he bought the company and he jacked the price up to $700. So patients, imagine that you're taking a certain drug for something that you need treated and you're paying $13 for it, and then all of a sudden the next day you have to pay $700, or I think it was upwards of $700. Right? It was a hugely controversial thing. It was all over the news. I think he did a couple of interviews on CNN trying to rationalize why he did it. But basically, the reason why he was able to do this and get away with it for a certain period of time was because that drug had perfect inelastic demand. Because if it was a regular, or like most goods and services, if the price was here and he jacked it up to here, then usually that quantity demanded would go down. There would be some kind of trade-off, but there was no trade-off in this case. Because people needed this drug, that quantity demanded stayed the same, right? And so their profits increased by a lot from them jacking up that price. And it was a hugely controversial thing, and it's just an example of a product that had perfect inelastic demand. So that's one end of the spectrum. So what about the other end? What about if a product is perfectly elastic? Actually, you know what? I'm going to keep that coefficient written out here. Got the percentage change in quantity demanded, percentage change in price. But now, instead of the coefficient, I'll keep that too. Instead of the coefficient being 0, now that coefficient is going to be infinity. How do we get that? Well, the way we can get infinity is if the denominator in this case is a very small number, or something very close to 0. It can't be perfect 0 because you can't divide by 0. It's basically where that infinity symbol is coming from. Technically, a number divided by 0, or as that denominator approaches 0, the whole value approaches infinity. Anyway, we're getting a little bit into math now, but point is that it's basically flipped. So we got a number over a very small number. So how is this scenario going to look graphically? So we got the price over here. We got the quantity demanded down here. And so let's say that a certain product has a price over here. Let's call it P0. And let's say that at this price, the quantity demanded is down here. Well, what's going to happen if a good has perfect elastic demand is it's so sensitive to changes in prices that even if we change the price by a very small amount, right, very small number, very small change in price, so let's say we drop the price to P1, what's going to happen is that demand is going to shift all the way over here. There's going to be this change in demand even with that small change in price. So remember, perfect inelastic demand, that was goods that didn't have a lot of substitutes or competition in the market. Well, perfect elastic products have a lot of competition in the market. So if you're going to increase, so let's say you're here and you increase that price of your good or service by even a little bit, that quantity demand, it's going to go down because everyone's going to just go to the nearest competitor, right? So this is an example of a very competitive market. And so if you connect these two dots, notice it's pretty much a horizontal line, or very close to a horizontal line. And so when you see this horizontal line here in your textbooks, they are describing goods or services with perfect elastic demand. So very small change in price, and then that quantity demanded is changing by some kind of number. Okay, and that's when you do this, you're going to get infinity for that coefficient, that price elasticity of demand coefficient. So it's a horizontal line versus perfect inelastic demand products. It's a vertical line. So a common example that's used to describe this is if you have two vending machines selling the exact same product. Let's say it's like a bag of chips, right? The exact same bag of chips, exact same quantity, exact same company, and they're both selling for $1. Both vending machines are selling both bags for $1. So probably what's going to happen is that these guys are going to split the market 50-50. Some people are going to buy from here, some people are going to buy from here. But what would happen if this vending machine decreases the price to 95 cents or even 98 cents, something very small, right? Everyone is going to buy this bag of chips here, just because it's just a smaller price. Even though it's a very small decrease in price, just 5 cents, it's still a smaller amount. And it's a direct substitute to this one. Okay, so everyone's going to buy the cheaper one. And then the opposite, let's say that they're at $1, and then this vending machine increases the price to like $1.05. Well, now everyone's going to buy from this vending machine. Right? So that small change in price, that quantity demanded is changing by a lot. So that's an example of products that would have, or a scenario where there would be perfect elastic demand. Basically, there's a direct or exact substitute nearby, very easy to buy it if that price of the original product goes up. Everyone's going to go to the substitute. And if that first vending machine decreases the price, then everyone's going to come to the first vending machine. Right? So two different scenarios that can happen. Perfect inelastic demand, perfect elastic demand. Now, one thing I want to note, for everyone who kind of remembers slopes of lines, if you remember, a vertical line has a slope that's undefined, or we can say it has a slope of infinity, versus a horizontal line has a slope of 0. So some students sometimes get confused about this, because notice that this here is a horizontal line, but that coefficient is infinity. And then the vertical line for perfect inelastic demand, the coefficient was 0. But notice it's the opposite of the slopes of the lines. And the reason why is because if you remember the slope of a line, it's basically the rise over run. It's the change in the y over the change in the x. But this coefficient here, it's the opposite. It's the change in quantity demanded, which is on the x-axis, and then the change in price, which is on the y-axis. So this coefficient here isn't the slope of the line. It's not the same thing, right? It's actually the reciprocal of the slope. Because again, a slope, it's change in y over change in x, while this coefficient is the change in x over the change in y. Okay, so just a source of confusion for some students sometimes when they start thinking back to high school math, slopes of lines. They get confused, especially with this horizontal. They know that a horizontal line, if you remember from calculus too, slope of a tangent, 0. But then this here, the coefficient is infinity. And it's because the coefficient and the slope of a line are not the same thing, right? The coefficient is the reciprocal of the slope. So that's the last thing I wanted to mention. in case that crossed your mind. But yeah, that's pretty much it. So perfect inelastic, perfect elastic demand, basically the ends of the spectrum. When you got perfect inelastic demand, that coefficient is going to equal 0. When you got perfect elastic demand, that coefficient is going to be infinity.